All right, simplify the trig expression to one trig function to the second power. All right, so if I'm looking at this, I don't see a way of combining the tangent and the sine squared. There's not an identity for those two. So what I'm going to try is I'm going to distribute this cosecant squared inside. Okay, so it's going to give me cosecant squared times tangent squared minus, and then the cosecant squared times the sine squared is going to be 1, and that's because those are reciprocals. Cosecant squared, that is 1 over sine squared. Tangent squared is sine squared over cosine squared. Okay, the sine squareds are going to cancel. So I get 1 over cosine squared, which hopefully you see that's going to turn into secant squared. Yeah, you have a 1 over cosine squared, which will become secant squared minus 1. And I'm betting that that is something to do with tangent squared. Let's see. Secant, so if I move the 1 over, yeah, I get secant squared minus 1, which is identical to tangent squared. Okay, this becomes tangent squared. That's it. All right, number 5. Simplify the expression. All right, notice here there's nothing to the second power. All right, I can't use any reciprocal trig functions like there's no secants or cosecants floating around. So I'm going to solve this one by expanding again, all right, where I multiply it out like I did this one. Cosine times cosine is going to give me cosine squared. This is going to give me a cosine times sine. This is going to give me a cosine times sine. So that's going to give me 2 cosine times sine. And then the last bit will be sine times sine. Sine squared. All right. I've got a positive sine squared and a positive cosine squared. I can trade that out for a 1. Sine squared plus cosine squared is 1. And then I still have the 2 sine cosine. And I believe that's my answer. Yep, that's it. Option A. Okay. Let's save this one for another video.